for today, we are going to just do a couple problems here, and we'll look at a little bit of the theory of the gas laws. I want to start with a simple problem involving the molar mass of a gas. Now, remember, simple, easy are not the same thing. So if you think, oh, wow, that doesn't look easy, that's okay. It should still be simple, though, and we'll see why here. I'm going to start by reading the problem. So in order to find the molar mass of a gas, a 0.208 gram sample was contained in a 500 milliliter flask at 23 degrees Celsius. If the pressure in the flask is 2.32 atmospheres, what is the molar mass of the gas? So we need to do a few things. Now, our ideal gas equation does not have molar mass in it, okay? So we need to use our simple substitution. Remember that moles can be calculated by finding the mass over the molar mass. Remember, I use the capital cursive M for molar mass. And as we do this, we can do a simple substitution. PV is equal to mass over molar mass, RT. Or if I want to solve this for molar mass, I multiply both sides by the molar mass and divide both sides by RT. Sorry, I divide both sides by PV. So I get the molar mass, which I'm bringing this up, is equal to MRT over PV. Now looking back at the problem, we have a few things that we know. I know that my gas has a mass of 0.208 grams. That's equal to the mass. I also know that the temperature was 23 degrees Celsius. That's the temperature. And I have a volume of 500 milliliters and a temperature or a pressure was 2.32 atmospheres. So in order to solve this problem, we need to keep it simple. We need to pay attention to R. So the value of R that we use is going to be important. So we're going to use R is equal to 0.08206 liters atmospheres per mole Kelvin. Now when I look at my values here, I find that my grams, okay, mass is in grams, that's okay. Temperature is in degrees Celsius, I will need to convert that to Kelvin. My volume is in milliliters, I need to convert that to liters. And my pressure is in atmospheres, my R is in atmospheres. So I can easily use these values here. Now I'm going to do a quick conversion of a couple things. And if you need, you can ask me a question about it, I'll show you how that works. But finding M, 0.208 grams, times R, 0.08206 liters atmospheres per mole Kelvin. My temperature, 23 degrees Celsius. Remember that in order to go from degrees Celsius to Kelvin, we add 273. So this ends up being 296 Kelvin. And my denominator, pressure times volume. Pressure is 2.32 atmospheres. And I know that there are 1,000 milliliters in a liter. So I can use that as a conversion factor to get 0.500 liters. Now what's nice about this is when I calculate it all, I end up with grams canceling. Oh, they don't cancel. So let's go back here. And I'm probably going to edit this. Okay. And I probably should calculate the answer. So I will go through and do an edit. 0.208. Okay. So this is the point at which I'm going to edit. Okay. So 0.208 grams. My grams, there's nothing to cancel grams with. Kelvin is going to cancel here. Liters are going to cancel here. ATMs are going to cancel, leaving me grams over moles, which is indeed the units for molar mass. And when I multiply this all out, I should get 44.0 grams per mole. And this is the problem we have. Again, is it easy? I don't know. Is it simple? Yes. We have an equation. We have everything but one known for it. So we substituted for everything else and we punch some buttons in the problem. Simple solution. Now we're also going to take a look at the van der Waals equation. And you're wondering, we haven't talked about the van der Waals equation yet. But in a way we have. So we have the ideal gas equation, PV equals nRT. And if we remember, when we're talking about the molar mass, okay, let's edit. Let's start again. Let's just stop there and start again.